Hello guys, welcome back to my YouTube channel. So now we are going to solve question number 2 of weekly contest 423 adjacent increasing subarrays detection 2. Okay, so we have given an array nums of n integers. Your task is to find the maximum value of k for which there exist two adjacent subarrays of length k such that both subarrays are strictly increasing. Okay, so in the last video we have covered part 1 of this problem, and now we are going to cover part 2. Okay, so in part 1 k was given to us, but in part 2 we have to find the k, okay, maximum value of k, and the problem statement is same, okay, mostly. So check if there are two sub arrays of length k starting at indices a and b. A is less than b. Both sub arrays are strictly increasing. The sub arrays must be adjacent, means that this b is starting from a plus k. We have to return the maximum possible value of k. Okay, a subarray is a contiguous non-empty sequence of elements within an array. Okay, so if you guys haven't solved part 1 of this problem, then I suggest you guys to solve first part 1 and then come to part 2. Okay, so now here see this example number 1, nums. I will provide the link of part 1 in the description of my YouTube channel. Okay, so here see this nums array. Okay, so here 7 8 9 is strictly increasing, right? And this is starting point, let's say. So a is the index number 2. Okay, it's the starting point. And if I say that k is equal to 3, okay, so if I add k is equal to 3 here, so what is the output that I'm getting 5, and let's say 5 is b. Okay, so here see, at this index, let's say I'm starting b. Okay, so 2 3 4 is also increasing, right? The subarray starting at index 2 is this one, it is increasing. The subarray starting at index 5 is 2 3 4, and it is also increasing. Okay, and these two subarrays are adjacent, and 3 is the maximum possible value of k for which two adjacent strictly increasing subarrays exist. Okay, so this is what we need to do. We have to find k here in part 2. Okay, so I hope that you guys are clear with the explanation. Now you guys can pause the video if you want. Now I'm going to show you how I'm going to solve this problem. Okay, so now first thing, here I will find the strictly increasing number of elements, okay, after that particular index. So here let's say I am here. Okay, so at this position only 1. Okay, and at this 3 1, so 3, and it is decreasing now. So here I am going to write 1 only. 4 3, so it is decreasing, so I am going to write 1 only. So now here 3 3 and 3, after 3 there is 4 which is greater than 3. So here I'm going to write 2. Okay, because 3 4 are one combination, right, which is strictly increasing. Okay, 3 4. So here 2 3 4. So here I'm going to write 3. Okay, so 2 3 4 is one combination. Okay, and then after that 9. So after 9, it's a smaller element. So here again I'm going to write 1. 8 8 9 is one pair, so 2. 7 8 9 is one pair, so here I'm going to write 3. 5 7 8 9, so here I'm going to write 4. 2 5 7 8 9 5. Okay, so from 2 there are 5 elements which are strictly increasing. From starting from 2, from 5 there are 4 elements which are strictly increasing. From 7 there are 3 elements which are strictly increasing. From 9 there is only one element which is 9 itself. Okay, so that is why this is what we need to do. We have to pre-compute increment length. We create an array increment length where each element at index I stores the length of the strictly increasing sequence starting from I. Starting from the end of nums, we initialize last value as 1 since there are no elements after the last one. Okay, and here how we are going to calculate index 9. Okay, so here see what I'm writing, 5 4 3 2 1 3 2 1 1. Okay, so this is what we obtain. Okay, so you guys can go over this. Okay, how we are filling this. Okay, so in the end we get this output. Then we have to do the binary search on k. Okay, so here what is the smallest value of k? It is always going to be 1, starting from 1. Okay, there may be one pair. Okay, strictly increasing, we can say that one element. Okay, so that is why I'm going to take left as 1, and right is nothing but max value. What is the max value we can get? Okay, left is the minimum value that we can obtain, right is the max. So max is let's say 5 5 5 5 pair. Okay, total elements is 10, and we have to find k. Okay, so we have to find two arrays. Okay, so if I divide the two arrays into half, then let's say total size of nums is 10, and I divide them in half, so then 5 is the max, right? So that is why my right is going to be n divided by 2, total number of elements divided by 2. Okay, so this is the max. Okay, now I'm just going to find the mid. So mid, simple formula. Okay, we have to find the mid. and after calculating the limit we have to check if there are any two adjacent increasing subarrays of length k is equal to 3 using can find adjacent increasing subarrays. Okay, so here see, this and this, okay, both are adjacent, and from here we will directly find there are three elements after this index and after this index. So this is what I'm to do. Okay, check k is equal to 3 using this. For each index we check if increment length of I, we have already filled the values in this, is greater than equal to 3, is greater than equal to 3, I is equal to 0, and here 0 plus 3 3. Okay, so here I'm getting this. So 2 is greater than equal to 3, false. So here I'm getting 4 is greater than equal to 3, 1 is greater than false. Okay, this become false, and here 3 is greater than equal to 3, and here also 3 is greater than equal to 3, so I'm returning true. So since we found two adjacent increasing subarrays of length k is equal to 3 starting at indices 2 and 5, so we are going to return true. We are going to update result as 3, and we are going to set left is equal to 4 to search for larger k. So for k is equal to 3 we get the answer. Now let's check other possibilities. Maybe k is greater than 3. Okay, so for 4 I did, so my mid I am going to increment it become 4. Then we have to check if there are any two adjacent increasing subarrays of length k is equal to 4. So I is equal to 0, I is equal to 1 I will do, and I will see that this is going to return false. Okay, so since all are returning false, and in the end we are just going to return the last result value. Okay, result is equal to 3. Okay, so here this is the code. Calculate the size, pre-compute the length of increasing sequences starting from each index, binary search. Okay, while left is right, less than equal to right. Okay, so in the end when you see my left was 4 and my right was 3. Okay, in the end, so that is why I just come out of this loop and return the result, which is nothing but 3 in the end. So here this is how my this code is going to work, right? Simple, same simple thing, right? Whatever I've explained. So here you guys already know why I'm writing 2 into k, because we have to find the two adjacent sub arrays, right? And I have explained that in part 1. So I hope that you guys are clear with this question number 2, and if you guys still have no doubts, then please ask in comment section. Thank you.